Hi guys, this is Module 5, this third section. It's having to deal with vectors. A vector is a quantity that has both direction and magnitude. The vector AB is shown where A is the initial point. We've got an initial point down here, and B is the terminal point where it ends. If it is drawn down here at 0, 0, the same one, that is considered in standard form if it's at the origin. The component form of a vector is given by the horizontal movement, so how far it goes over this way, and how far it goes up. You can get that by doing x2 minus x1, because here's your x1 value and x sub 2 value. So you would subtract that to get your horizontal component. And the y sub 2 minus y sub 1 would give you the vertical component. The magnitude of a vector is found by the distance. It's how long it is. That's the magnitude. And the distance formula is the difference in the x's squared plus the difference in the y's squared with your square root over top of it. It is from the Pythagorean theorem, how we get it. So that's why we got the squares involved. The magnitude of a vector would be given by that same distance. All right, so right here, the component form of a vector, movement left or right and movement up or down, just like we had before. You've got A, B. So I'm going from A, 1, 2, 3. So my horizontal movement is 3. And then up 2, 1, 2, 2. There's the component form of that vector. All right, AC. The horizontal movement is 1, 2, but it is negative 2 in this direction. The vertical is up 2, which is a positive 2. DE is negative 1, is your horizontal movement. And then 1, 2, 3, negative 3. FG, F to G is, I am moving horizontal 1, and I am moving vertically 0. Right. FH, I am moving horizontal 1, positive, and then down 2. For JK, it is horizontal 3, positive, and vertically positive 1. So that's how to write the component form of the vector just by counting it off on the graph. So right here, find the component form and the magnitude. So you have the component here is going to be negative 6 minus 0 and 3 minus 0, which gives you negative 6, 3. And your magnitude is that same thing, only squared. Okay, so we end up with the same negative 6 squared plus 3 squared, which is 36 plus 9, or the square root of 45. That has a perfect square involved of 9. So the square root of 9 is 3, the square root of 5. So there is your magnitude. And you write it just like that, the magnitude of P cubed. And there's the component form. So let's try it a second time. You've got 4 minus 2 is your front. 4 minus, oops, sorry, it's not your front one. I'm doing the, I think I switched over into slope all of a sudden. So what you've got here is the horizontal movement first, 5 minus 0, and then the vertical movement, 4 minus 2. So that gives you a component form of 5, 2. And your magnitude is 5 minus 0 squared plus 4 minus 2 squared, which gives you 5 squared plus 2 squared, or 25 plus 4, which is the square root of 29. There isn't anything you can do with that. And that is the magnitude of PQ. Okay? This one should be turned in. And you'll find the component form and the magnitude. Okay? Two vectors are equal if they have the same magnitude and direction. They are parallel if they have the same or opposite directions. And they are perpendicular if they are at 90 degrees to each other. So in this diagram, these vectors have the same direction, AB, CD, and EF. They're all headed in the same direction. Okay? So they're all parallel to each other. They are equal if they have the same magnitude and direction. So that's what you get right here with the AB and the CD. 1, 2, 1, negative 2, 1, negative 2. So they're equal. They are parallel if they are in the same or opposite directions. GH is also parallel to these three because it's in the opposite direction. Okay? So just little looking out at those. Okay. Direction. The direction of a vector is determined by the angle it makes with a horizontal line. When you're doing real-life applications, you use the directions north, east, south, and west. The x-axis is the east-west line, and the y-axis is the north-south line, just like on a map. So if you're describing the direction of each vector here, this is 25 degrees south of east. So in the east direction, you're going south. It's 25 degrees south of east. This one right here is going in this direction from the north. So you're going to say 35 degrees east of north. This is where you are starting your movement to the vector. This is your direction it's moving in. Okay, so 25 degrees south of the start point, east. 35 degrees east of the start point, which was north. So right here, an airplane lands 40 kilometers west and 20 kilometers south from where it took off. The result of the trip can be described by the vector negative 40, negative 25, because that's the direction they went. Negative 40, negative 25. Use the distance for magnitude and direction to describe this vector a second way. So you're going to need to get that angle so we can describe what it is south of west, what angle we've got. So if you want to find the direction, we are going to do our trig that we've done before. It is the opposite and the adjacent, so that's tangent. So the tangent of x equals negative 25 over negative 40. And that reduces by 5 to 5/8. So what you're going to put in your calculator is tangent of -1 of 5/8. And that, the arctangent, sorry, is 5/8. Okay. So your angle degree is 30, well, that's x, sorry. And you got 32 point, it's actually 0.1 degrees. So we can just go with 32 degrees and call it good. Okay. So you would describe this as 32 degrees south of west. That would be your direction. Your magnitude. Okay. Well, here they don't give us the coordinates, but you don't need them. You've got the entire distance, so you can go with your Pythagorean theorem straight off. -40 squared plus 25, -25 squared. Take the square root and you will get your distance. So this is the square root of 1600 plus 625 equals the distance. And you have the square root of 2225. Square root of 2225 is 47.2. 2225. And that is approximately 47.2. That is the magnitude of that vector. All right, it's about 12 minutes now, so I'm going to sign off. We'll do the second video in just a second.